Namaskar my dear friends. Let us write a code for plotting a spiral of Archimedes. So we have a spiral of Archimedes. You can see it looks like this, a spiral kind of shapes, and the equation for this spiral of Archimedes is basically r equal to k theta, where k will be a constant and theta will be the angle that is varying. So if you take one of the example, let us say this one. So as theta is increasing, my spiral is increasing. Okay, so let's say k is equal to, let's say 2 multiplied by theta is, let's say 1 radian, 2 radian, like that. It will be keep on increasing, and this is how the value of rho, that is r, will be changing. Okay, so this is how we will be plotting it. So let's open MATLAB and do this code. So this is my MATLAB code. We can take up a new script. Just write down a program, spiral of Archimedes. Okay, now what we will do, we'll try to basically understand. Let's say we define a step size of 0.01. You can define any value that you want. Okay, so step size equal to this much. Now I am going to define the value of theta. Okay, so that will be going to be, let us say we start from 0 angle to, with a step size up to, let us say 2 pi we will go. Okay, so 2 into pi. So we have defined a theta vector from 0 to 2 pi, so that will be just one circle or one cycle. Now let us define a constant value k, which will be, let us say 2. Okay, this constant can be anything, 220, 200, 500, anything. Now my value is what? R is equal to k theta, right? So k multiplied by theta, that's all. So this is all the program is that is needed. Now we can initialize a figure. Let's say we give number 1, and then what do? We can put polar plot theta comma rho or theta comma r. So polar plot theta comma r. Okay, so you will see the polar plot of this particular spiral of Archimedes has been plotted. So let's run this program. It is asking for code name, so we will write it down, Archimedes spiral. Okay, now once we run this program, we can see the figure has been plotted with, this is the spiral of Archimedes. Now it has been plotted for only up to 2 pi. 2 pi means 180 degree, right? So 0 to, it started from 0, so 0 into k, that is 0, and as theta is increasing, my r is increasing, so slowly the radius is increasing. Okay, now let's make it much better. If you want to plot up to 4 pi, so one more cycle will plot. So if you run this, you will see one more cycle has plotted. If you want to increase to up to 8 pi, so it can go even more. So this is how it can be plotted. And as you can see, for the value of k, the k is reaching like 20, 40, 60 based on the values of like r and theta. So the value of r will be increasing based on the value of constant k. Now let's make it much better. We will plot the same Archimedes of a spiral with different values of k. So let us say we have a vector k1 of different constant, let's say 2, 10, 100. Okay, so let's say 3 values are there for k1, and we want to plot r equal to k1 into theta, right? So we can start a for loop for I is equal to, we'll start with 1, like first values of up to what? Length of k1, right? Length of k1. So it will trace first value 2, 10 and 100. Now what we can do, we can start the vector r, which will be equal to k1 of ith, means first value of I, second value of I, third value, first value of k1, second value of k1, like that, right? And then theta. And then we can initialize figure as well. Let's say we do not want to override this figure, so what we can do is we can write down figure I plus 1, so that the figure name will be 2, right? And then we can put polar plot theta comma r. So I can just take this same thing here and end the program. So for has to be written with a int statement so that it can plot it. Now the value of k is 2, then k is 10, then k is 100. So you can see first figure will be same as this one, and then next figure will be a little bit higher, like strength or higher amplitude, right? So we'll just run the program. So we have figure 2 which will be up to this one, then figure 3 you can see the value has changed to 100, then figure 4 has value changed to 1000, like that it is changing, correct? Now let's say if you do not want to change this figure, so what you can do is you can do this thing and put figure, and I can put this polar plot r comma theta and then put hold on. So it will plot in the same, it will plot on the same figure, so it will not initialize any other figures, right? So I'll just put close all so that all the figure are closed. Okay, I don't have any figures, so only one figure will be for first one and another figure will be for all the three values of k. Let's see how it shows. So once we run it, we are seeing here, okay, it has not done that because it is not able to hold here. Okay, no problem. Actually it has always started new figure, that's the reason it didn't do that. What I will do is I will start a figure here so that it doesn't overwrite that previous figure, and then we can do that. Now if you run, let's say close all, so all the figure has been closed, and now you run it. So this is how you figure out all the things. So you can see for the k value of 2, the blue color will be there, which is very small, that was for value k equal to 2. Then for k equal to 10 is the a little bit red color, and then for k equal to 100 this is the yellow color. So this is how it is happening. Okay, so alright guys, hope you have understood how to draw the spiral of Archimedes for different value of k and theta, and you can keep initializing as long as you want. And if you want to take user values of theta, you can take it like theta is equal to input, put theta value like like minimum value or maximum value that we have already talked about in the user input codes, right? Thank you so much.